So now that we've actually went over the task events portion of sending and receiving triggers, we're going to talk about the method of using inline script, so adding a little bit of code in order to send triggers. So as I mentioned, if you are using ePrime 2.0 standard and you're not using professional, you will need to use a little bit of script to send triggers to external devices. If you're interested in getting 2.0 professional, so that you can use task events, we do have an upgrade available to go from standard to professional at a discounted rate. So if you are using standard, support for sending a signal to an external device, any other machine, whether it's EEG or another response device, it's available in ePrime through port communications. So if you actually go into ePrime and actually take a look at eBasic help, you'll see that when you type in the parallel port device, for example, you'll see that there's quite a bit of information under parallel port device, such as how to configure the port and also how to reset it or to set a bit. So anything that you're trying to do, there is a list of what's available in eBasic help. You could also write through your own Windows DLL. There are some users that have done that as well. Now, the address of your port can be found, as I mentioned, by selecting System from the Windows Control Panel and then going through the Device Manager. So it's important to remember that if you are selecting the parallel port, you want to find the LPT or printer port. And then you're going to actually click on the Properties button and the Resources tab. That will actually let you access the port that you need. The port address may also be specified in decimal or hexadecimal notation, as I mentioned. So when you're using hexadecimal notation, you want, with eBasic, it actually requires to put the ampersand and H to be inserted prior to the address. So there's a lot of coding and scripting where that is required. For example, the most common actual parallel port address that is used in decimal, as I mentioned, is 888. So with that, it'll actually translate with the hexadecimal notation to 378. And this would then be written in ePrime as ampersand H378. So I think we do have that written here in our notes. So as I mentioned, you're going to check your device manager and properties to find the address of your port. And then when you're using the hexadecimal notation with eBasic, you do need to put that ampersand and H, which needs to be inserted right before the address. Now some just general information about the bits used with sending triggers. The value parameter, you can also basically write it in decimal or hexadecimal notation, as I mentioned. So the value is translated into binary notation. So this represents a specific bit pattern. This is kind of just the very kind of the foundation of this sending triggers with this method. The bit pattern then corresponds to the pin connection. So bits are either 0 based or 1 based, and pins are always 1 based. So you have to remember that when you're writing to the parallel port, you are actually sending 8 bits of data at once. So you'll actually write a 1 to any bit whose corresponding pin you wish to turn on, and a 0, you would want to write a 0 if you're actually wanting to turn that pin off. So bit-to-pin mapping is basically standard for the parallel port, and we actually recommend that you look at the documentation for your hardware and your port address for a mapping of bits to pins, just to verify that it's the same. And it's also important to note that the first available bit-to-pin connection begins at bit number 1 and at bit number 2. So you cannot send a signal to pin number 1. So we actually have, I actually have a little graph here. This chart is actually available in the documentation that we've sent in the materials that talks about sending and using a parallel port to send triggers. So this pin is there, this pin chart is there, as well as a diagram that shows you the bit to pin mapping. I will pull that up for your reference. I believe it's in How to Communicate with Parallel Port. So this will be in your materials. And if you actually scroll down, it actually talks about basically what we're going to cover in the webinar, but there's pictures available. And then there's actually this, which talks about the output pins as well as input pins. So this is a very helpful document to take a look at. So as I mentioned with the standard parallel port, you can actually assume that the pins 9 through 2 correspond to the number 00000 whenever the pins are all off. And you want to match up the number values with that notation. So using the binary system, the number values of the pins 9 to 2 are 1, 2, 8, 64, 32, 16, 8, 4, 2, and 1 respectively. So you'll see that's listed here in this order in correspondence with the pin. If you want to turn on pin 9, you must send a value of 128 to the port. So that's just an example of that. And if you want to turn on pin 2, you must send a value of 1 to the port. And as I mentioned, this table illustrates the standard pin mappings and corresponding decimal values. And if you want specific information, I recommend following the article that we sent with your materials. Before I go into the details of this slide, I want to actually open up the basic port sample experiment that we've sent with your materials. This actually talks about bit to pin mapping as following the documentation. We actually recommend sending the signal to the port by setting the onset and offset of the signal properties. So first we're going to look at the view and the actual script, that the user script that we recommend, first setting the constant. So you'll see here that the base address is set at 888, which I talked about is usually the standard address. And then you have to also note the out port address as well as in port. Now in this we're actually using some red lamp and green lamp, but you'll see that we'll have the flashing of these colors by actually writing to the port. So in the green, you'll see the comments explaining that flash lamps are basically to make sure the port address is correct. So this is kind of a little check that's available in the beginning of the sample experiment. So it's going to write a value of 255 to the port, and that'll actually turn all the bits on. So this does that. It does a little sleep statement as well to give it a break, and then it'll write out to the port. And the write port command requires 2 parameters. You need the port address, and then you also want to specify that constant in the user tab, which we've already done. So after those bits are set and the lamps are checked, we're going to actually initialize the lamps to turn them off. And as we mentioned, to turn anything off, you would use a 0. So we're going to use the 0 there. And if you notice, we're writing to the port here. Then after feedback is given, a score is calculated, and even with that, it's going to actually turn the green lamp on as well as shutting it off by writing the 0. So it's a lot of kind of just repetitive writing with this code, but it will allow you to do exactly what would be able to be set with task events. You just have to write a bit of script in order to make that happen. So as I mentioned, that the receipt and handling of the signal by the other machine is actually kind of the responsibility of the user. But in terms of the ePrime side of it, you can write with the write port command, and ePrime can actually, it may use this to trigger the event. So you can actually signal an external device to begin data acquisition, or you can also notify the external device of an event, basically in order to mark the event in the data collected by the external device. With the parallel port, it is best to use the onset and offset signal properties. So you'll see here we actually have this actually is writing to the port, but here we talk about the best way with parallel port. One thing that I mentioned with task events is you can actually set the onset and offset signal to occur right there on the property page of each object. So if you have a stimuli slide that's showing a movie or a sound and you want the signal to be sent at the onset of it, you actually would be able to just set all of this information right in the task events property page. But writing it out, you'll see that we actually recommend with ePrime that you want to use the practice with the parallel port of actually using the onset and offset signal properties. So these properties will allow triggers to be sent at the exact time of an object's onset and offset, and it will actually greatly improve your ability to keep timing consistent with stimuli. So ePrime is very keen on having great millisecond accuracy. So using this onset as well as offset will make sure the timing lines up. Now you'll see here the X actually is just a placeholder. This is where the actual name of the object would be. So if your stimuli slide is called stimuli text or something like that, it would be stimuli text dot onset signal enabled. So X is just the placeholder for the object name. You can also find these properties fully documented under the general RTE runnable input object topic in eBasic online help. So if you want to know more about setting this, you can look in eBasic. And you also want to note that you will need to specify the address of your port via the signal port. So that's why we have this x.onset signal port. This is where you're actually going to put your specific port information. And then you're also going to, and the value you are sending via the signal data. So you also, kind of what we showed with task events of picking the data that you want sent or the value you want sent. You can do that right in task events, but here you would need to actually specify that value using this data and then this port command for the port that you're going to be using. So the onset and offset signal basically directs ePrime to internally send a specific value to a specified I/O port at the exact time a stimulus onset or offsets. So the I/O port used is typically a parallel digital I/O port rather than a serial port. Each bit within the port has some assigned meaning by the researcher, so it's important to kind of customize your experiment to what you have set in your computer. For this type of signaling, you can typically use the built-in parallel port, or also you can register an addressable digital I/O card. We've had users do that as well. And if you use the default parallel port, there's typically no hardware initialization needed. If you're using a third-party digital I/O card, you often have to configure the card once at the beginning of the experiment by using the write port command. And this write port command is also covered in eBasic help. And this allows you to send a value to a configuration basically that's designated to basically configure the port that you're going to use. And this step typically programs the registered port on the card as input or output. So if you're using that digital I/O card, there is a way to do that. And if you need specific help with that, you can contact our support department. But you would also want to refer to your card's programming manual for specific instructions on how to kind of set that up with ePrime. So the next slide talks about if we actually, here we assume that the object's name are prime and probe. So it's kind of similar, but we're actually showing you that the parallel port address of &H378, as I talked about the standard address, is used in the following example. And if you wanted each object to send a signal to the parallel port upon its onset, you would create an inline object at the beginning of the experiment. So that's important to note that all of this would have to be in the beginning, either in the user script or at the way beginning of the procedure. And this allows ePrime to know that you're going to be referencing the prime and probe slide, and you're going to be sending signals at the onset and offset, as well as the data and the port address that will be sent. So in that example, actually, prime sends a signal to bit 0, and probe sends a signal to bit 1. And each time the object is run in the script, this will happen. It's typically only necessary to set these properties once at the beginning of the experiment. Then anytime these are fired, this will send the signal. If the onset signal data value changes under some conditions, you will need to change the value of the property in an inline that runs prior to the object. So if there's any customization, you would want to make sure you set it. But if there is no changes throughout the experiment, this will actually allow, just setting this once in your experiment will allow these signals to be sent throughout the experiment. So going back to the actual sample experiment that we talked about with the basic port address, this was demonstrating communication using a parallel port, and the program that's been designed here illustrates communication with the device connected to the parallel port, and the device used to design this experiment was a single button response device with 2 LED lights, as I talked about, using green, and I believe the other color was red. So this is a response device, and the mapping of these components is as follows. There's a red lamp is bit 2, green lamp is bit 1, and the button would be bit 7. So you'll see here that I think there is the, this is where it's actually going to specify which color. So you'll see there's green and red, and the green is actually signaled with the bit 2. Sorry, the green is bit 1. Now, the port device is also enabled in the experiment object devices, and you can actually use that. You can input the port on the stimulus object if you want to collect it that way. The bits to watch for in the input are designated in the input properties for the stimulus object. So if you go to the stimulus object here, and you actually go to the properties and the duration, you'll see port address is signaled there. So you can specify that as well. And what's happening in this experiment is basically the program will present a subject with a fixation and then a stimulus X or Y, and the subject is to respond by pressing the button on the device when an X is presented. And then when a Y is presented, the subject should not respond. So the input is scored for accuracy and reaction time. So you'll see that that's all set up in inline script. If you did use if you use professional, you'll see task events is available. With task events, you can actually just add, as I mentioned, what you want to do in terms of press or release of the button, and you can use a port address here, and then that way you can actually set the action and add the devices here, and then also set the data type and what type of action you want for that specific response or event. So this is the way to set it without using task events. Now with socket communication, you would actually use the same command as the serial device. So we don't really need to go into detail about that. But what I do want to mention is if you do have a specific question about socket device, we do have a knowledge base article, and I think that we send that with our materials. I believe, I want to double check. I think it's sent with the materials that we gave you. Yeah, there is actually a how to communicate with serial ports. So if you're interested, that's covered in there. So once we have our serial port configured, and it's a COM address, we can actually change the properties in the experiment to match it. So this, I'm actually now going to open up the serial port example, the sample experiment that we've sent you. So in the serial port communication example, this ePrime program actually waits for a signal from a device connected to the serial port, and then it runs the trials. And during the trials, the response is written to the serial port. So you would actually want to make sure that is set correctly by setting the inline script right after the wait display. This is actually just holding the experiment until some bits arrive over the serial port. So it's kind of checking the serial port here. And as I mentioned, you can refer to serial device and eBasic help for more information about that. And one method to send triggers using the serial port is the write string command. So you'll see that we actually do use the write string here after feedback is given. Send the object's response key to the remote terminal you're going to actually use the write string command to send that response. So whatever response was given to the stimulus slide, and you'll see here under the property pages, there is no pre-release set because we want actually the inline script to check what is given on this particular object. And when the response is submitted, we're going to use the write string command. This method will not guarantee that the signals are precisely synchronized with the stimulus, but it will send that information and send that trigger. And to enable a write string pulse that is sent before the onset of an object, you will then use the following script in the inline where your write string information is customized to your experiment. And that's where you will write serial.writeString stimulus.response. And that's what we use here if we want to make sure that write string, that pulse is actually sent right before the onset of the object. Now this assumes that the serial device is added to the experiment and that the serial communication properties, port ID, and all that information are configured the same on both machines. So that's kind of the takeaway with using inline script. You want to make sure that both machines or both devices are integrated correctly. So this approach attempts to send a signal at a consistent one-screen refresh before the stimulus. So the best you can hope to achieve using the secondary approach is some constant signal time before the stimulus. So you would also want, as I mentioned with pre-release, to make sure that it's not set whenever script is involved. We do have an article on our website about pre-release if you're concerned with using pre-release and script, because you want to make sure that the setting is correct. Usually the tech consultants, we always recommend putting pre-release to 0 on any object where script is following it. The other thing that you could do is send the signal after the stimulus is presented, and this approach requires that you set the pre-release property for the object to the same value as its duration. So that actually forces the object to exit its run method and to also basically exit as soon as the stimulus is finished being presented, and then you would want to send the signal by inserting an inline right after the object. So there's actually quite a bit you can do in customizing with using this inline script method. And as I mentioned, one method that's very common with the serial port is using the write string command, and we have an example there. Before I end, I want to actually just talk a little bit about Chronos that I mentioned. This is the new response system that we have that integrates greatly with ePrime. A lot of our users have found this to be very easy because if you are using ePrime 2.0 Professional, it will integrate with using task events. So you actually don't have to use any inline script in order to use this system as a response device. This does come with a microphone as well as a photo sensor, so you can actually detect your refresh rate of the screen. And if you would need any customization with your experiment, such as a foot pedal, or if you want to use any I/O expander, which would allow you to actually set up another external device through this Chronos system, that's something that a lot of our users have been doing. It makes the connection with ePrime a lot easier than actually having to map out the connection with your own either parallel port or other port address. I'm just going to open up one of our experiments just to give you an idea of what you would do if you wanted Chronos to be added. You would actually go to your experiment object properties, go to devices, and add the Chronos system. And there's a lot you can do by clicking on this in order to set its actual properties. So if you would like the mode of collection to only be press or release, you can do that. You can also do emulate, and you can adjust a lot of properties here. These are the LED lights that I mentioned. There's quite a bit of colors available if you want to set each of the buttons to a specific color. And then we also have audio out. This sets things with the microphone, audio in. One thing that is very, very helpful with reaction time and recording is that with Chronos, you can actually set the recording to begin of the voices only when the voice has started or when the person has started to speak. So that cuts out any of the silence or anything like that before the person begins to talk. The recording will only start at the onset of when they start speaking, and that removes, kind of factors in the threshold component of it. The photo sensor is, as I mentioned, if you want to know the actual rate in terms of the refresh rate. And then once it's added to your experiment object properties, you can actually set it anywhere in your experiment. So let's suppose we want them to respond to this stimuli that's presented by using Chronos. We will go to task events and add. You'll see that it's already in there as press or release. So I'm just going to do press of the button rather than release. And then I'm going to have to set the specific task. So I'm going to use Chronos for the task. So even though it's added here as an event, you want to make sure that you specify that you want the task, the task device to be only Chronos. Then we're going to actually, if you want to delay, as we talked about, you can set the 50 millisecond delay or anything like that. And then the action, you can actually see that there's quite a bit with the Chronos that you can do. You can do digital output and analog, as well as just the LED color, the LED state. You can write a bit, write an integer, toggle bit, set bit. It's all already coded in there. And then once you actually set one of those, let's just say we do LED color, and then you can do the source to be custom. You can just have it with the response or the reaction time, and then you can set the data type. We'll do long, and then you can actually just hit OK. So that means when this stimuli is presented, the person will respond using the Chronos device, and that can actually be sent to notify for the triggers that you would want in terms of this actual specific response to this object. If you would like more information about the Chronos system, I definitely recommend checking out our website. And the end of the webinar today, I just want to mention that we do have articles on our website, as I had previously mentioned, regarding using a parallel port. Also, if you are using a serial device, you can look into that, into the article regarding using that. And there's quite a bit of information and kind of what we talked about today that will be covered in the articles. And if you have any other questions, please feel free to submit a support request, and our technical consultant will get back in touch with you. And if you are interested in any of our products, whether it's the Chronos system or any of the extensions we have that interface with eye trackers or eFMRI, you can contact our sales department at sales@pstnet.com. and they can give you pricing information. As I mentioned, if you are planning to use external devices and you don't want to have to code or script, you can always make sure that you are using ePrime 2.0 Professional to reference the task events feature that I mentioned, which makes it a lot easier to send triggers and to interface with an external device that way. So thank you so much for watching this webinar today. Please let us know if you have any questions through our support portal, and hopefully we can help and assist in your experiment design to make it a lot easier if you are using an external device.